So in this video, we'll be looking at using trigonometry to find a side given a length and one side. So we're trying to find a missing side. All right, so I've got this right angled triangle in front of us, so we can see that little square over there shows it's right angle. Well, that square just means it's 90 degrees. And I've got this little arc here with the symbol theta inside. Well, that symbol just means that there is an angle there, right? So we think about maybe this length down the bottom here as probably like, say, a road or some kind of land or surface, and we've got this ramp going up top. So that angle determines what is that ramp sitting on, what is the angle of that ramp is sitting on. If you think about maybe a roof as well, this could be probably like your ceiling over here and the roof going down in that slant as well. Right, but it's important when we're doing this, we determine what our sides are and what their names are as well. All right, and this will come in handy when you apply trigonometry to solving a problem. So first things first, the longest side of the triangle or the ramp is called a hypotenuse. Hypotenuse. All right, and we can just define that as capital H. All right, the side right opposite the angle, okay, that side right there is called the opposite. All right, also we can write this as just O. Cool. And the last side, which is down the bottom there, okay, we call this adjacent, okay, because it's adjacent to the angle, and we can just write that as capital A. All right, so we've got O, A, and H, and we come to this idea of SOH CAH TOA. Now write it down, SOH CAH TOA. All right, this thing will be very useful when you're solving using trigonometry. Alright, so SOH is just this S over here just means sine, okay, or the angle or sin, the trig function sin, and you've got opposite and hypotenuse. This over here is cos, okay, and you've got adjacent and hypotenuse. And yes, this over here is tan or tangent, and you've got opposite and adjacent. So how we write this down is we write it as sine theta, so sine, some angle, is equal to opposite over the hypotenuse. So the opposite length over the hypotenuse length. All right, cos theta is equal to the adjacent length over the hypotenuse. And tan theta is equal to the opposite length over the adjacent. If you go to our calculator, we can see we've got sine, we've got cos, and we've got tan. All right, and we will use our calculator to determine what our lengths are. All right, so let's look at an example. Right, I've been given a triangle that has an angle over here of 30 degrees and a length of 7, a hypotenuse length of 7, and I'm trying to find the length that it's opposite to. So again, I go back to my idea of SOH CAH TOA. Okay, well, if I look at it, I'm trying to find the opposite, and I've been given the hypotenuse, so I'll use SOH. I can't use CAH because I haven't been given the adjacent length, but I've been given the hypotenuse, but I can't use it. And I can't use TOA because I'm trying to find the opposite, but I haven't been given the adjacent. So that's why SOH is the best one to go with. So what I'll do is I'll write my function out. So I've got sine of 30 degrees, which is the angle, is equal to the opposite, which is x, over 7. All right? And now what we're going to do is we're going to isolate that x and solve. So I can rewrite that by rearranging as x is equal to 7 multiplied by sine of 30. So what I'll do is I'll go to my calculator and I can go 7 sine 30. And I get negative. So what's really important, since that's happened, I need to go here and check. My angle needs to be in degrees, okay? Because it should be in degrees because we're dealing with degrees over here. So I'll do it again. 7 sine 30. and I get 3.5. So therefore that length, x is equal to 3.5. So this is 3.5. The height of that triangle is 3.5. Now let's look at another example of the same idea with SAW, but this time we're going to try and find the hypotenuse. Okay, so over here just below I've got another example. Okay, I've been given the opposite. I'm trying to find the hypotenuse. So again, we'll use the idea SAW again. Alright, but this time what I want to do is I want to have sine of 30 equals to 5 over x. Now this will require a bit more rearranging compared to the last one. So what I could do is I can write down as x multiplied by sine 30 is equal to 5. Therefore x is equal to 5 divided by sine of 30. So therefore I go to my calculator and I'll have 5 divided by, and I like putting brackets around this, sine 30. And I get 10. So therefore in this situation, my hypotenuse is equal to 10. Alright, so we've done two examples trying to find the opposite or the hypotenuse length using SAW. Now let's look at another triangle over here. Alright, I'm going to just get rid of this 10 for now. Okay, so again, I've got a right angled triangle with an angle of 40. I haven't been given the opposite, but I'm trying to find the adjacent. I've been given the hypotenuse. So in this situation, we're going to use CAH. Alright, so cos of 40 is equal to the adjacent length, which is x, over the hypotenuse, which is 10. Alright, and what I could do is I can rearrange and have x is equal to 10 multiplied by cos of 40. So x is equal to, and in my calculator again, I'll go 10 cos 40. And I get 7.66. So 7.66 is this length right here. Okay, so a bit of rearranging, but we've used that idea of SOH CAH TOA. Okay, we've seen that we're trying to find the adjacent, but we've been given the hypotenuse and we've been given an angle, so we can use CAH. Now remember, going back to the last video, is if we were given two sides and we're trying to find a third side, we will use Pythagoras' theorem. But since we've been given one side and one angle, and we're trying to find a side, therefore we will use trigonometry over here. Cool? So now let's look at another example. Now over here, same, we're going to use CAH again, but in this situation we're going to try find the hypotenuse. So we've got cos of 40 is equal to 6, the adjacent length, over the hypotenuse, which is x. And similar to the SAW situation, we'll have x is equal to 6 divided by cos 40. I'm skipping the rearranging step there, just so I can show you how it looks. Alright? Therefore, x is equal to, and I'll just put it on my calculator, 6 divided by cos 40. So we get 7.83. Okay, rounded. 7.83. Okay, so the similar situation, we rearrange. Because we're finding the hypotenuse, the rearranging is slightly more, but we use that idea again to just find the length. Alright, now let's look at another triangle over here. So we've been given we're trying to find the opposite length, but we've been given the adjacent. So over here, we're going to use TOA, right? Where tan of an angle is equal to the opposite divided by the adjacent length. Okay, so I can rewrite that as tan, replace the theta with 55 because that's the angle. I'm trying to find the opposite, so that's x divided by 4, alright, because that's the adjacent length. So therefore x is equal to get rid of the 4 on this side, we multiply by the 4, and we multiply the other side by 4 as well. 4 multiplied by tan of 55. We can put that in our calculator. So 4 tan 55. Okay, you can write down 4 times tan 55, but 4 tan 55 just means multiplying, which is 5.71. So x is equal to 5.71. Alright, just remember this is pretty much saying 4 times tan 55. So if you want, you can write that as 4 times tan 55. Remember that angle is attached to the tan, so you're not multiplying that 55 with the tan, it's attached to that angle. Alright? So again, you get the same answer there. Alright? Now, last triangle we'll look at, again, using that idea of tan or toa. Alright, we've been given the opposite length, we're trying to find the adjacent. So we've got tan of angle 55 is equal to the opposite length, which is 3, divided by the adjacent length, which we're trying to find, which is x. And again, we rearrange. Okay, tan of 55 equals 3. And we want to isolate the x. So x equals 3 divided by the tan of 55. Okay, don't treat the tan and the 55 separately. Remember, they are together. Okay, and therefore x equals, so put that in my calculator. We get 3 divided by tan 55, and we get 2.10 rounded. Alright, so we can find that the adjacent length is 2.10 rounded. Okay, and we've just used trigonometry to solve these problems. So remember, SOH CAH TOA. Okay, sine of an angle equals opposite divided by the hypotenuse lengths. Cos of an angle equals the adjacent divided by the hypotenuse length. And tan of an angle equals the opposite over the adjacent lengths. Okay, so just a key thing to remember. Alright, that is what we're trying to do using trigonometry. SOH CAH TOA. So if you remember that and you keep practicing, that will help you a lot.